Good afternoon to all of you, my dear students. Uh, Today we will discuss about various types of strain gauges. Before that, we will go for what we discussed in the previous class. In the previous class, we discussed about that electrical strain gauges. These electrical strain gauges that when that means when the force is applied at the end of the conducting wire with some diameter, then it undergoes for some elongation, that is a DL. Thereby, it is based on the strain. So all of you know that the strain is nothing but change in the length divided by the original length. So here in this, when the conductor, when you apply a force at the other end, then it extended by a length of DL, change in the length. That is, DL is the change in the length to the original length. That means here the stress is developed in the conductor, thereby the strain is induced into it. So for that, the resistance of a conductor R is equal to rho L by A. R is equal to rho L by A, right? Rho L by A, right? Strain is nothing but gauge factor into dr by R, right? Correct. Dr by R. Okay. Strain, that is when you consider that is negligible, that is some factor is there, that when you consider that negligible, it is right. Strain is equal to gauge factor into dr by R, right? And then next here, and then we discussed about R is the resistance of a conductor, R is equal to rho L by A. From that equation, we will go for a differentiation by applying logarithms. After that, we have to go for differentiation. And then according to the principle of that Poisson's ratio, that is lateral strain divided by linear strain. In the lateral strain means that means a negative strain. Lateral strain is nothing but a negative strain. Linear strain or longitudinal strain is a positive strain. We discussed that in the lateral strain, it occurs in the diameter, and whereas in the case of that linear strain, it is occurred in the length. That means already last class we discussed that one, and we derived about that gauge factor. Gauge factor is nothing but the other word of gauge factor is sensitivity, gauge sensitivity factor. It is a gauge sensitivity factor. So here we can the gauge factor. What one person said that right, dd by d by dl by l, correct? Gauge factor is nothing but 1 plus 2 Poisson's ratio, right? In that Poisson's ratio, strain is nothing but here Poisson's ratio is lateral strain by linear strain. So okay, right, correct. Gauge factor is proportional to the resistance. Resistance, right? Right, very good. Strain is nothing but gauge factor into dr by. Here the strain is nothing but dl by L. Am I right, Mr. Raviteja? dl by L. Strain is nothing but here dl by L. Yes, right. Very good. Right. So last class we discussed that derivation. It's a very, very important derivation. And the expected question in the end semester as well as in the mid. Remember this point. The next today we will discuss about that different types of strain gauges. So it's very, very simple and easy. The first one is here. See, it is unbounded strain gauges, unbounded strain gauges, and unbounded strain gauges and bounded strain gauges. Two are there. So now we'll discuss these two, unbounded strain gauges and bounded strain gauges. So here this it looks like a cantilever beam. If you observe, this is a cantilever beam in that two frames are there. One frame is P and another frame is Q. So and these are that insulated pins. These are the four insulated pins are arranged. at the corner. See here, these are the four insulated pins. These are the four insulated pins are arranged at the corner, right? And then see here, these two frames which are relative to one another, and an unbounded strain gauge of some small thickness of a small diameter, you have to structure on the insulated pins. We have to structure on the insulated. See here, we have to structure on the insulated pins like this. That means you bending here, from here it goes to here, and then it again bending, and then in this insulated pin again it is bending like that. So these are the four insulated pins and unbounded strain gauge. So when the force is applied at the end, what happens means these frames undergone stress. When the force is applied means there will be deflection takes place, some bending takes place. When the force is applied at the end, what happens means there will be a bending or a deflection takes place. So what happens means the stress developed in that frames, that is frame P and Q. That means what happens means when this one it bends in this direction, when the force is applied downward, then automatically stress developed in these two frames. Thereby, what happens means a strain is induced in it. That strain we have to measure. So here, these are the, see here, these are the strings, wires. So these, with the help of this unbounded strain gauges, which is arranged or structured through with the insulated pins, then what happens means these strain gauges is nothing but it is like a wire. It is like a wire. So yesterday I see, actually I shown to you different types of strain gauges with some conductor wires, right? So here, again I'm repeating, all of you listen carefully. When the force is applied, what happens, the next step is, these two frames undergone stress. Thereby the strain developed. So with the help of this unbounded strain gauges, which strain gauge or wire, so there will be a change in the resistance. So once there will be a strain is developed in the frames, automatically this wire absorbs that one, and thereby what happens means there will be a change in the resistance of the wire, of the bonded strain gauge wire will take place. So this bonded that means this wire, we have to connect it to the one of the resistor of the Wheatstone gauge. Sir, almost all these strain gauges are mainly depending on the principle of Wheatstone gauge. Sir, these wires, we have to connect these wires, we have to connect one end, and the other end we have to connect to the one of the resistor of the Wheatstone gauge. Here, when the force is applied, what happens? There will be a change in the resistance occurs in the gauge. So when it is connected to the one of the resistor of the Wheatstone gauge, once that there will be a change in the resistance, automatically the galvanometer deflects. This galvanometer is proportional to the strain developed in the frame when the force is applied. 1 minute. Okay, right. See here again, I'm repeating. Here it consists of two frames, frame P and Q, which are relative in motion. On that, four insulated pins are there. These four insulated pins. Here the wire, that means is structured through the four pins, and then when the force is applied at one end of this cantilever, it seems to be cantilever, then automatically what happens means that there will be stress developed in these frames. So once the stress developed in the frame, then automatically strain developed. So that is absorbed by these wires, though, so thereby there will be a change in the resistance in the wires takes place. This wire is connected to the one of the resistor of the Wheatstone bridge. Once there will be change in the resistance takes place means automatically the galvanometer deflects. The change in the galvanometer reading is nothing but which is proportional to the uh, strain developed in the frame. Next, we'll go for the next one. Bonded strain gauge. In the bonded strain gauges, three are there. One is a fine wire strain gauge. Another one is a foil wire strain gauge. Another one is a semiconductor strain gauge. The three gauges now we'll discuss one by one. So 1 minute. Wait a minute. The next one, fine wire strain gauge. This, see here, if you observe, here it consists of here strain gauge bonded, strain gauge bonded to structure. This means this is the structure here. This is the structure, right? Here, this is a strain gauge which is in the form of bending. It is in bending. This is a strain gauge of, and these are the leads. These are the leads. These are the two are the leads, and it is 0.025 millimeter diameter. See how it is very small. It's very sensitive. It's almost all the strain gauges are very high sensitive. 0.025 millimeter. 0.025 millimeter. So here this is a fine resistance. This is a fine resistance wire. This is fine resistance wire. This is fine resistance wire for 0.025 millimeter diameter, and this is a strain gauge, this shape, strain gauge bonded to the structure. This is a structure. See, this bonded means bonding with the help of the adhesive material. Adhesive material, we have to attach that strain gauge bond, strain gauge we have to attach to the structure whose strain has to be measured. So this strain gauge is complete strain gauge. See here, we have to attach on the structure, that is bonded on the structure whose strain has to be measured. And then this is, see here, this is, if you observe here, this total material is, this total material, 1 minute, this is not appeared clearly. I taken the snap, not bright. It is a carrier base material. This is, this material is a, this material, all of you observe here, this material is a carrier based material. Carrier, that means paper, bakelite and Teflon. It is made up of paper, bakelite and Teflon, this one. And then this is nothing but fine resistance wire, so which is of 0.025 millimeter, We have to bend again and again, which is shown in this figure. Clearly, this is bending. That fine resistance wire is bending. And these strain gauges we have to attach or bonded on the structure or frame whose strain has to be measured. So by additive materials, we have to bonded with by additive materials. So here, when the force is applied, if you observe clearly, when the force is applied, uh, when the force is applied in these two directions, then what happens means in the structure, stress developed. Once the stress is developed, means thereby the strain is induced in it. Strain, pipe joints, Teflons. Okay, okay, Teflon, right? It is made up of Teflon. This is made up of Teflon. And then what happens means strain is induced in it. We have to measure that strain. So for that, what we are doing, we have to attach a strain gauge with the help of the additive material. This is made up of paper, bakelite, and Teflon. And a wire is there, which is bent again and again. See here, if you observe clearly, these are the two leads. These are the two leads. So this diameter wire is 0.025. What happens means when the force is applied, there will be a change in the resistance of the wire takes place. So these leads we have to connect to the one of the resistor of the Wheatstone bridge. So what happens means there will be a change in the resistance takes place. So what happens, it leads to change in the uh, galvanometer reading. This galvanometer reading is proportional to the strain developed in the structure or the body. It's very, very simple. All strain gauges, we have to work on the principle of the strain gauges, right? And then next we'll go for the next one. This is a second one, semiconductor piezoresistive strain gauge. Semiconductor piezoresistive strain gauge. So here in this, if you observe clearly, same principle here also. Semiconductor piezoresistive. I think all of you know that piezo means that when the force is applied on that, it undergoes some deformation. Thereby, some resistance takes place in that material. Maybe there will be a change in the dimensions, or maybe there will be a deformation takes place. So here in this this semiconductor strain gauge, you observe clearly. So here it consists of a structure under study. This is a structure under study. So that means when the force is applied, whose strain has to be measured. So in that, see here, this is a plastic polyester, plastic or polyester, and then which is bonded to the structure or body, so by some additive materials. I think all of you know that about the additive materials. What are the additive materials? Anybody? Additive materials, bonding. What are the additive materials? Anybody? Additive. Right, very good. Gum, paste. Gum. So just we have to attach on the ceramics. So it is nothing but paste or gum, right? So here this is a semiconductor. If you look into this is a semiconductor. What is the meaning of semiconductor? Partially conduction takes place. In the previous, it is fully conduction, but here this semiconductor wire or piezoresistive material, that is nothing but partially conduction. Partially conduction means, that means all of you know that partially conduction. Piezo means or piezoresistive. Piezo means it's a material, it's a magical material. When the force is applied on that, automatically there will be change in the dimension of that particular material. So here these are the two leads. We have to connect it to the one of the resistor of the Wheatstone bridge. Here when the force is applied at the two ends, that means a tensile force, then what happens means here there will be a change in the length, and in the change in the length. That means length, that means elongates. So due to tensile force is applied on the both the ends of the structure or a body, so thereby the strain developed in the body. So once the strain develops here, that force is also acting on this material. So thereby some changes are taking place, or some resistance taking place inside the wire of the piezoresistive wire or a semiconductor wire, then which is connected to the one of the resistor of the Wheatstone bridge. So thereby what happens means deflection takes place in the galvanometer, which shows that or which is proportional or which is calibrated in terms of the strain developed in the structure. So almost all the wires are we have to connect to the Wheatstone bridge. So these are the wires are simply like it seems to be a resistance wires. It's a resistance wire. The next, the third one is metal foil strain gauges. This is a metal foil, right? If you observe clearly, this is also the same principle. This you observe clearly, this is a metal foil. This is a metal foil. Foil strain gauge, metal foil strain gauges, and thick ends. That means having the diameter of this metal foil is about 0.02 millimeter thick. That is 0.02 millimeter thick. 0.02 millimeter thick, right? Right. So at this same procedure, here at this point we have to go for a soldering, and this total box, this one is metal foil strain gauge bonded to the structure or a body whose strain has to be measured. This is bonding will take place with the help of the adhesive material, and this material, this lining material is a plastic baking, and this is a metal foil, right? And the ends are very thick, and when the force is applied, what happens means stress developed, which leads to development in the strain in the structure. So here these leads are connected to the one of the resistor of the Wheatstone bridge. Thereby what happens means then automatically resistance, change of resistance takes place. When the force is applied, automatically there will be change in the resistance. So the galvanometer deflects, which is proportional to the strain developed in the structure. I hope so all members understood. This is three of what we discussed before, or the same principle, right? Same. So actually this is used for measuring of a force and also pressure. For example, load cell is there. I think all of you know that if you go for any kirana shop, then you need 1 kg of dal or 1 kg of tur dal, like that. So what they have to place on that weighing machine. This weighing machine is based on mainly on these strain gauges, and these strain gauges, the ends of the wires is connected to the Wheatstone bridge. So thereby we can get the weight which is displayed in the device. Same here in our lab it is there. Load cell is there in the lab. So while doing experiment on that, you can get much more knowledge on that this Wheatstone bridge. So any questions please regarding? Actually the time is up to 2 to 2:50, almost a 2:40 is there. 2:40 time is over. Any questions? And then next is here in the strain gauge has to be adhesive materials. So that means the materials are adhesives or paste. These adhesives are called as bonding materials or cements. So, and also different adhesive materials are there. What are those? thermoplastic cement, thermosetting cement, special ceramic cement. So with the help of this one, we have to attach that whatever that metal foil or unbounded, that is bonded strain gauges, metal foil or semiconductor gauge, we have to bond with the help of these materials to the structure or the body whose strain has to be measured. The characteristics of these adhesive materials, if you observe clearly, it is insulator, should be an insulator of electricity. That means non-conduction of electricity and absorbs and should not absorb humidity and should not go along with the baking material, should not be affected by temperature changes, should have good shear strength and transmit a force from structure to wire. It's very important. This is very important. So whatever the force is applied on the structure or a body, that should be transmits from the structure to the strain gauge or wire, and should be easy to apply, spread easily. Right, Feviquick also, it's a gum, right? Should provide good bonding, right? So these are the main thing. And then the materials, now we'll discuss about, this is the bonding material. So whatever the strain gauges, may be metal foil or bonded or semiconductor strain gauges, we have to bond to the structure or a body whose strain has to be measured. That bonded, these are the materials and these are the characteristics required for that. These are the characteristics required for that, right? And then next, what are the materials of strain gauges? Right now, here we will discuss what are the materials of strain gauges. Actually, the slide is there I prepared, but it is gone somewhere. But anyway, I will discuss some materials of strain gauges. It is made up of the strain gauge, whatever the metal foil and semiconductor and other bonded strain gauges. That material, actually, it's made up of nichrome, that is 80% nickel and 20% chromium, and isoelastic, that is 36% nickel, 8% chromium and 0.5% molybdenum, and constantan 45% nickel, 55% copper and nickel platinum. So these are the materials used for strain gauges, right? And these, the properties of that materials used in the strain gauges, it should be high gauge factor and high specific resistance and high good corrosion resistance. So here these are the properties. First is high gauge factor, high specific resistance and good corrosion resistance. So, but anyway, actually I prepared that one. The slide is somewhat here. I came to the college, but it is in the home. Actually, when I send after completion of this unit, you can get all the points clearly. What are the properties of the strain gauge material, and what are the materials, like that, correct? I will give the notes material to you. No problem. Now all of you respond attendance one by one. Respond attendance one by one in the chat box. Section A first. So 1 minute, I will take the rough paper. Okay, respond one by one. Number 80, 18th batch, 18th batch or not? 18th batch 320 and 81, right? 81. 81 option to right. Okay, next one, number one. 81 present, okay, right. 2, 1 option 2. 3 right. 4, 5, 5, right. 6 present. 6 option to must. 7 present, 8 present. 5 present, okay, right. 7 was also present. 9, about 9. 9 option. 10, 10, 10. 11, 12, okay, 13, 13, 14, 14, right, 15 present, okay, 16, 16, kucho, 16, 17, 18, 18, 19, 20, 21, 22, 23, 24, right, 25, right, 26, 27, right, 26 option, 27, 28, right, next, 29, 29, 27, 28 present, okay, right, 29, 30, 31, 32, 32, 33, 33, 33, 30, okay, 31 present, 33 option, 34, 35, 36, 37, okay, right, 38, 39, 40, 40, right, 41, 43 present, 44, 45, 46, right, 46, okay, 45 option, 47, 48, 49, 48 present, 49 present, 50, 50 more, 51, right, 52, 53, right, 54, 55, 56, 57, 58, 59, 59, 60, right, 58, 59, 60. Lateral entry 1, right. One option, lateral entry 1 option, 2, right, 3, 4, 5, 5 6, 7, 8, 9, 10, okay, present 11, 12, 13, 14, 15, 16, 16, 17, 18, 19, 20, 21, 22, right, 18 present, 18 option, 19, 20, 21, 22, 22, 23, 24, 25, 26, 27, 28, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 45, 46, right, 47, 48, 49, 50, 51, 51, 51, 51, okay, right, 52, 53, 52, 53, 54, 55, 55, 56, 57, yes, okay, 329.